Respected my class in charge and my dear friends, a very great morning to all of you.
Very great morning, Anshu.
Myself Anshu from Proud 12 Science Standard today in front of you to deliver speech, and my topic for speech is magnetism, which is related to our subject physics. So what does this term magnetism mean? We all are familiar with this word magnet from our earlier classes. Magnetism is a physical phenomena of magnets to show the property of attraction or repulsion. Both electricity and magnetism have been known 2000 years ago, but it was about 200 years ago that it was realized that these both concepts were interrelated to each other. During a lecture demonstration in the summer of 1820, a physicist Hans Christian Oersted found that a straight current carrying conductor causes noticeable deflection in the needle of magnetic compass. He investigated this phenomena. Oersted found that whenever a straight current carrying wire AB is kept with the magnetic compass in such a way that current flows from point A to point B, then the north pole of a magnetic compass get deflected in the west direction. And when this experiment is repeated, but this time the straight current carrying conductor is kept below the magnetic needle, the north pole of a magnet get deflected in the opposite direction. So what conclusion can be drawn from this experiment? A simple conclusion is that magnetic fields lines have opposite direction above and below the when straight current carrying conductor is kept above and below the magnetic compass needle. Oersted experiment led to the discovery that when electric current is passed through a conductor, magnetic field is also generated around it. If strong current is passed through the conductor, strong magnetic field will be generated and vice versa. Then how we can find the direction of this magnetic field generated? How we can know that it is whether it is in inward direction or outward direction? Two simple rules are there, that is right hand thumb rule and Maxwell corkscrew rule. Right hand thumb rule states that whenever we hold current carrying conductor in the palm of our right hand in such a way that thumb points toward the direction of the flow of current and the direction in which finger curl gives the direction of magnetic field. Second rule is Maxwell corkscrew rule. If a right-handed corkscrew is rotated so as it moves in the direction of the flow of current and its rotation is in the direction of the flow in the direction of magnetic field. Let's move to the concept of magnetic field. The space around a magnet or simply current carrying conductor in which its effect can be experienced is known as magnetic field. This term is analogous to the term electric field. Electric field means the space around electric charge in which its effect can be experienced, but there is some difference between these both terms. The basic difference is that source of electric field is an electric charge, which is a scalar quantity, and the source of magnetic field is the magnet or current element, which is a vector quantity. Second difference is electric field lines start and end at some another point. It means that they do not form closed loop, but in case of magnetic field they originate and terminate at the same point. It means that they form closed loops. A bar magnet or simply a magnet has two magnetic poles, that is north pole and south pole. What does the term magnetic pole means? Magnetic poles are the preferred regions of attraction near the ends of a magnet where the magnetic force is found to be maximum. It is a magnetic pole. The poles of a magnet are located near the ends of a magnet, not exactly at the ends of magnet. Let's move to some of the properties of a magnet. The first property is attractive property. We all know about attractive property, that whenever a piece of substances like iron, nickel, cobalt are kept with a magnet, they show attraction. The attraction is maximum towards the ends of a magnet and minimum towards the center. Next property is directive property. Let us suppose we take a magnet and this magnet is suspended freely. So this magnet will align itself in the direction along the geographical north-south line. It means that south pole of a magnet will be towards the south pole of the earth and north pole of a magnet will be towards the north pole of the earth. Next property is like charges, like poles repel each other and unlike poles attract each other. It means that let us suppose we take two magnets each having north and south pole. Whenever the north pole of a magnet is kept with the south pole of another magnet, they would show attraction because they are unlike charges. But when the south pole of a magnet is kept with the south pole of another magnet, they would show repulsion because they are like charges. Next property is magnetic poles always exist in pair. As I have told you earlier that there are two magnetic poles, that is north pole and south pole on a magnet. An isolated magnetic pole does not exist. Suppose we take a magnet and we cut this magnet in the transverse direction in the two equal pieces, and each two pieces will have north and south pole. The north and south pole do not get separated. Whenever the magnet is cut into the transverse direction, then the magnetic strength will be same as that of original magnet, but when it is cut longitudinally, its magnetic strength will reduce to half. Next property is induced magnetism. It's very easy. Like we take a magnet and we keep some pieces of either iron, nickel, cobalt, etc. with the magnet. They would show attraction. This acquired magnetism property is known as induced magnetism. Next property is repulsion is the surest test for distinguishing between a magnet and iron rod. If we have to distinguish that whether the specimen is iron rod or magnet, a simple thing is we should keep those substances with the ends of a specimen. If it would show repulsion, then surely it would be an iron rod, but if it show repulsion at one end, then it would be a magnet. Now let's discuss some of the important terms, that is magnetic dipole and magnetic dipole moment. Magnetic dipole is the arrangement of the magnetic poles of equal and opposite strength which are separated by a finite distance 2L. These are known as magnetic dipole. Magnetic dipole moment is the product of magnitude of either pole strength multiplied by. Magnetic dipole moment is defined as product of strength of either pole and magnetic length of a magnet. It is represented by the capital letter M and its formula is M into 2L. Its units are ampere meter square. Let's discuss about magnetic length and geometric length. Magnetic length is defined as the distance between two poles of a magnet, and geometric length is the distance between two ends of a magnet. There is a big difference between these both terms. Magnetic length is always less than the geometric length. This is all about my topic. Thank you and have a nice day. Now let me ask some questions from you. My first question goes to Aditya. Aditya, what is magnetic length?
It is the separation between south pole and north pole of a bar magnet.
Right answer. My next question goes to Parveena. Parveena, what is the unit of magnetic dipole moment?
The unit of magnetic dipole moment is ampere meter square.
Right answer. And my next question goes to Lavish. What is the difference? State one difference between electric field and magnetic field.
Electric field